Now, a lot of people got a bit confused with these challenge questions, okay? Now, I did make them a little bit difficult, and I am sorry for that. The big thing here that I think confused a lot of you was when we used multiple atoms, okay? So with CO3 2-, what that means is that we have CO3 and the entire bubble, okay, the carbon, oxygen, and 3 of them combined gives us a total charge of -2. So when you're trying to solve this question, don't try to break them down individually. There's no need, okay? All that hard work's been done for you. So you simply look at sodium, so Na, has a charge of +1, and our CO3 has a charge of -2. Now you can use the crossover method, okay? So you can move the 1 down, the 2 over here, and have Na2CO3. An alternative is that you can use the lowest common denominator. So, what do I have to do to each of these to multiply them into the lowest possible number? The answer is 2. So 1 times 2 equals 2, or 2 times 1 equals 2. The next one here was a little bit more tricky. And you have to break this one up because I didn't give you the charge. Okay, so this one is very unlikely for you to receive this in your exam. So, out of interest, how we calculate this sulfate is we look at our oxygen and we calculate the overall charge. So you look at the periodic table, you can see that oxygen has a charge of -2. Now there are 4 oxygens here, so we have to multiply this by 4. So that means that if we have 4 oxygens, it's going to have a charge of -8. -2 times 4. Now our sulfur, what's that going to be? The answer is +6. Now I may hear a lot of you go, well, what? Hang on. Sulfur's not a metal. It can't be a positive. It can't be giving away those electrons. You said it yourself. Sulfur. 1, 2, 3, 4, 5, 6. It's easier for it to steal 2 than to lose 6. Why is it a positive? Now, the answer for that is that it would prefer to steal 2. It would prefer to steal 2 electrons to fill its outermost shell. That is definitely easier for sulfur. Here's the thing. Oxygen is not letting sulfur do what it wants. It's being a bully, basically. In a competition between sulfur and oxygen in terms of pure muscle strength, who wants those electrons more? Oxygen wins. So it means that oxygen is going to be forcibly stealing these electrons from sulfur. So it's going to be stealing it from it, meaning that sulfur is +6. Why +6? Because that's all it has to give on its outermost shell. Okay? You can't just keep going down and just stripping all of the electrons, so it's bare, there's nothing left. Only the electrons in the outermost shell are up for grabs. Meaning that although oxygen would like an additional 2 electrons, it can't get them. Hence why SO4, okay, or sulfate, has a charge of -2. +6 plus -8 equals -2. -2 with our aluminium, which is +3. Okay, we can use, again, our crisscross method, or we can look at the math, and we can get here that it's 2 aluminiums and 3 of our sulfates. Now, you will notice that I've got these in brackets. What these brackets tell you is that we have SO4. So we have 4 oxygens and 1 sulfur. Now the 3 is on the outside of our brackets. What that means is that everything in the brackets here is multiplied by 3. Okay, so that was probably the most complicated and tricky part. The next part is looking at chemical equations. Now we're going to look much deeper into this next lesson, so next week. The big thing here is that I just want you to understand that chemical equations are just simply a method and shorthand way for scientists to write down exactly what's happening. Okay? Now it is very important to acknowledge the law of conservation of energy. Okay? It's also known as law of conservation of matter. Essentially what it says is that atoms cannot be created nor destroyed. The big thing is they are simply converted, okay? They are changed, they are altered in some way to change their form, to change their composition from one form to another. So this is what we see in chemical equations. Now, a couple of things here that is very important that you will need to know. You will definitely need to know what a reactant is, and you'll need to know what a product is, okay? The definition. So, let's look at this a little bit closely. So we've got an equation here. Now we all know our trusty friend H2O. Now it is made up of combining hydrogen, so hydrogen, a flammable gas, and oxygen, funnily enough, also a flammable gas. Now if we combine these two together, we will create H2O. And that's what this is telling us. So if we have our reactant over here, and we have our product. Now how I personally remember that is I remember it as the reactants react to form a product. Or the reactants react to produce a product. Okay, so that's just a little sentence thingy that I use to remember it. If you'd like to use something else, yeah, be my guest. But the big thing here is that reactants are on the left-hand side of the equation, and our products is on the right. Now we'll notice a couple of little symbols here. So G simply stands for gas, L is liquid, S is solid, and AQ, it means aqueous. It just simply means it's dissolved in water. So those are the 4 you need to know. Solid, liquid, gas, and aqueous, meaning that it is something that is dissolved in water. Now the last thing is our arrow here. The arrow simply says something happened. So to look at this equation, I could say I have hydrogen in one hand, I have oxygen in the other hand, then the arrow comes in, so something happens, we don't know. They get squashed together in some chemical mumbo jumbo, and ta-da, we have water. So all the arrow means is that something happened. They reacted. They did something. And that is our product. Now, there are many more symbols out there depending on the type of reactions, and many out there that give you a lot more information, including Greek symbols and other bits and bobs everywhere. Don't worry too much about that just now, okay? You only need to know at this level. So again, if you weren't quite sure, here are some of the symbols here. Don't worry so much about delta. Okay, we're not going to worry about this one here. Just focus on these symbols. If you know those, you'll be just fine. Big things to take away here, guys. Make sure you memorize the definitions and have an understanding of ionic, covalent, and metallic bonding. It is something that you're going to use again and again and again. Understand valence. Valence, in my opinion, is one of the most important things that you could learn in all of chemistry. Granted, it's also one of the most complicated, okay, when you get up to the higher levels. But valence electrons, once you understand those, and you can use the periodic table to predict the type of chemical bond, to predict the ratio of elements in a compound, especially when looking at ionic, in ionic compounds, but it allows you to predict and truly understand the behavior of some of these chemicals. And of course, just a quick definition list at the bottom here. So cation, so remember, something that loses or gains electrons to make it positive or negative is cation and anion. So cation, if you're losing electrons, it becomes positive. That's cation. And anion, if you're stealing electrons, you become negative. That's anion. If you move electrons at all, okay, if you lose electrons or gaining electrons full stop, that is an ion. Valence simply refers to the number of electrons in the outermost shell. Now we've got delocalized, okay, that simply means that it's not stuck to one nuclei, it's able to flow through, and we saw that with our metallic bonding. We have our reactants, okay, and our products. So remember that the reactants react to produce the products. Okay guys, good work today. I hope this helped. I'm going to be releasing this as both a podcast and a video. So if you guys could please just give me a bit of feedback on this, I would highly appreciate it. And also, if you'd like more of these sort of things in the future, I'll try to see if I can produce a few more resources for you. So keep up the hard work, guys. Keep up the study. Your hard work will pay off. And I'll see you guys next week in class. Bye-bye.